Now, in this video, we will be discussing the conformations of propane and butane. Let us move into it. Okay, all right. Now, the first heading you can write conformations of propane. Conformations of propane. Now, what is the formula for propane? CH3, CH2, CH3. Now, what we will do here is we will be considering either this carbon-carbon single bond or this carbon-carbon single bond, and we will be making the rotations across that carbon-carbon single bond. Okay. Now, suppose any of the two you can consider. So we are now drawing the Newman projection. So this is the front carbon. Suppose I'm considering this as the front carbon. Okay, and this is the back carbon. Now at the front carbon, we have 3 hydrogen atoms attached. And at the back carbon, there are 2 hydrogen atoms. And 1 CH3 group is there. 1 CH3 group is there. Now, this is the eclipsed form. Eclipsed form. Now you can understand why I'm calling it as eclipsed form, because here the hydrogen atoms are close to each other and there is maximum repulsion possible between the bond pairs. Okay. Now rotate it at the angle of 60 degrees. Now what will you get? You will get another conformation. So we can draw it like this. If I'm rotating in this direction, this CH3 will move here, H will move here, and this H will move here, this H will move here. So this is the now conformation. Now these bond pairs, the carbon-hydrogen bond pairs and the carbon-carbon bond pairs, they are at maximum possible distance. So this is the staggered conformation of propane. Staggered conformation of propane. Again, rotate it at 60 degrees. Now, again, it will lead to the formation of eclipsed conformation. So it will be here, CH3, H, and H. So while rotating, just keep one thing in mind, that you need to rotate in one direction. We will be rotating it in one direction only. So just like I have rotated like this. Okay. Now, next, we will be moving to the conformations of butane. Conformations of butane, very important and very, very interesting. Okay, so you can consider the molecule conformations of butane. So butane is CH3, CH2, CH2, CH3. Now we will be considering this carbon-carbon single bond, and we will be rotating across this carbon-carbon single bond. So I'm considering this as the front carbon and this as the back carbon. So at the front carbon, what is there? At the front carbon, 2 hydrogens are attached and 1 CH3 is attached. All right. Similarly, at the back carbon, there are 2 hydrogens attached and 1 CH3 is attached. Now this conformation, when the CH3 groups are exactly opposite to each other, it is known as fully staggered. Now why I'm using here the word fully, you will be understanding soon. So this is fully staggered, or it is also known as anti-conformation. So this is the most stable one. Most stable, because the bulky groups, they are 180 degrees apart. Bulky groups are 180 degrees apart. Now, just rotate it at 60 degrees. So again, front carbon we will be fixing and back carbon we will be rotating. So if the front carbon is fixed, this CH3 will be at this position, here H, here H. Now, this H will move here. The next H will move here, and here we have CH3. Now this is partially eclipsed. Or it is simply known as eclipsed. Now, why I'm calling it as partially eclipsed, you will understand in the next steps. Again, rotate it at 60 degree. All right. Now, in the same direction, you need to rotate. Here is CH3, here is H, here is H. Now this CH3 will move here. So here we have CH3, here we have H, here we have H. Now this conformation is staggered, but it is not fully staggered because the bulky groups are not at the maximum possible distance from each other. In this, we called it as fully staggered. Now this is partially staggered. Partially staggered. And the partial staggered conformation is also known as skew or gotch. Very, very important. Now, NT is going to be highest of the highest stability. Eclipsed, definitely it is always having lesser stability than staggered. Then again, now we are rotating it at 60 degree. So now what will happen? The two CH3 groups will come to the maximum closest distance. Maximum closest possible distance. So now this is fully eclipsed. Fully eclipsed, least stable. Because the bulky groups are very close to each other, bulkier the group, more is the repulsion. Bulkier the group, more is the repulsion. Now again, rotate it at 60 degree. CH3, CH3, H, H. Now again, we have got the skew or gotch conformation. Skew or gotch conformation. Then again, 60 degree. Again, what we will get? The fully, not the fully, but the partially eclipsed, because we are rotating in this direction. So we will be getting CH3, H, H. Here it is CH3, here it is H, here it is H. Now we have got partially eclipsed. Okay, now I think it should be clear to you that if the bulky groups are at the maximum possible distance, the repulsions are going to be the minimum and the stability is going to be the maximum. And if the bulkiest groups are very close to each other at the maximum possible closest distance, then the stability is going to be minimum and energy is going to be maximum. So let us now draw the energy level diagram for the conformations of butane. So I'm just clearing my screen off. So here you can take the similar curve. Here we have angle of rotation. Here we have energy. So the minimum energy will be of NT, that is the fully staggered conformation, because it is the most stable one. So it will be having the lowest energy. So this is the place for NT. You can draw if you want. I think I should give you this assignment. You need to draw this curve. Okay, take the picture and you need to put it in the comment section below. All right. So this is NT. Now, when we rotated the NT, what we got, just see the rotations there. I have cleared my screen. Just see the rotations in your notebook. We got the eclipsed or the partially eclipsed. Partially eclipsed. After that, we got skew or gotch. Now, always the eclipsed one is going to have the higher energy than staggered, and it will be lesser stable than staggered. Okay, so NT is the most stable. The second stability will be given to skew or gauge. Then third number will be given to the eclipsed or partially eclipsed. Here we have the maximum energy. It will be given to the fully eclipsed conformation. Fully eclipsed conformation. Again, after fully eclipsed, what we got? Just see the rotations. We got this Q1. Then after that, again, we got the eclipsed one. That is the partially eclipsed. And if you rotate the partially eclipsed further, again, you will get the NT. Now, what is your homework? You need to draw the structures of these. Just like if I draw the NT, it will be like this. Here CH3, here CH3, H, 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 H. You need to draw for all on the curve. Put that picture in the comments below. Second assignment for this is you need to write the order of stability of these, all these conformations which are possible in case of butane. All right, so now I'm stopping to share, coming back on screen. Hope this much is clear to you and you are finding it interesting. It is actually interesting. So you need to keep rotating. You need to fix one carbon, the other you need to keep rotating, and you need to keep looking at the positions of the different groups or the atoms. So with this, we are done with the conformational isomerism, and next we will be moving to the optical isomerism. See you in the next video.